Hello and welcome to my channel The Complete CSC Guide. I am Sanskriti, and in today's class we are going to discuss about the selective repeat request, okay, ARQ, that is your selective repeat ARQ. And this one is the third protocol, or you can say the third ARQ within the noisy channel, as we have discussed the previous that are the stop and wait protocol and the stop and wait ARQ and your go back and ARQ, and this one is the third one. Okay, so let's start with this, right? So first of all, let's have an introduction of what's this. Okay, now as you can see here, that introduction selective repeat request ARQ, that is your selective request ARQ protocol, is a crucial component in data communication and networking. Obviously it is also a crucial one, right? And it plays a it's in data communication and networking. Since we are talking about the noisy channel here, we have already seen in the noiseless channel what were the protocols, and here the automatic repeat request is the ARQ, which is the word which is used here, okay, for the noisy channel. Now let's see. It plays a pivotal role in ensuring reliable and efficient data transmission across networks, particularly in scenarios where errors and packet loss are common occurrences. So here the common occurrences, since we are talking about the noisy channel, so obviously the error, whatever the error control techniques we have to implement those techniques, right? Why? Since there are some scenarios where errors can happen and the packets can be lost. Okay, so these are the common occurrences which happens in case of some noisy channels. So obviously this particular thing is needed here. Now selective repeat ARQ represents an advancement over similar or simpler ARQ protocols, that is our stop and wait protocol or our go back and protocol, offering enhanced reliability and performance by selectively retransmitting only the lost or the damaged packets. So what happened in the previous protocols, what we were doing, we were simply sending the protocol, sending the packets or sending the frames, and what was happening there, we were sending the frames and we were getting some acknowledgement, right? So in the first one, stop and wait protocol, what we were, or ARQ, what we were doing, we were sending the frame and we were waiting, the sender was waiting for an ARQ, or sorry, for an acknowledgement, and when it was getting the acknowledgement, then it was sending another frame, right? And in go back and ARQ, what was happening there also, this happened that we were sending some frames. So there we were sending many frames, not one frame, but we were getting the acknowledgement for those frames. But at the point when the frame is lost, okay, so at that point what was happening, we were just sending all those frames up to the frame where we have got the acknowledgement, it's okay. Apart from that, where we were not getting the acknowledgement, we have to send all the frames from that particular frame, right? But here you have to send only the selective particular frames which you need to be retransmitted, not all the frames. Okay, so here some selective pattern is there, pattern is followed. Okay, so performance is selectively retransmitting only the lost or the damaged packets. In go back and there we were sending all the packets or all the frames which were damaged from the damaged frame which was identified from that particular frame. After that, whatever we have sent, we have again to retransmit the whole portion, whole each and every frame, right? But here we have only to retransmit the frame which is lost or which is damaged, right? So it's a very crucial point and it's a very good advantage of your this particular ARQ. Okay, so the protocols involved in flow control are shown below in this article. We can see, I will show you which protocols. So we will discuss the selective repeat ARQ since it's for this chapter only. In selective repeat ARQ, the sender sends several frames specified by a window size. Again, a window size is there, the sliding window protocol we are using here also. So send several frames specified by a window size without waiting for individual acknowledgement from the receiver, as we did in the stop and wait protocol, as in the go back ARQ protocol, both of them. Okay, so now next let's see what were the different protocols which we have already discussed. So these are the protocols: noiseless channels, simplest and stop and wait, and noisy channels, stop and wait ARQ, go back ARQ, now selective repeat ARQ. So these all things we have already covered. Now this one is the last one which we are going to cover today. Okay, so now let's see what's about this particular selective repeat ARQ. Okay, so selective repeat ARQ, what is that one? So selective repeat protocol, also known as selective repeat automatic repeat request, okay, that is your ARQ, is a data link layer protocol that uses the sliding window technique. Again, the sliding window technique is being followed here. I have already discussed about this in the previous class, you can see that one. Okay, so this technique I am not discussing today, for reliable data frame delivery. Okay, now only erroneous or lost frames are retransmitted in this case. In that case, particular case, what we were doing, we were retransmitting that particular frame obviously, and all these frames which we have already sent after that lost or damaged frame. So the whole thing you have to send again, retransmit again, but here only the particular thing which is damaged, that you have to resend. Okay, so while good frames are received and buffered, whatever good frames you are receiving, they are just buffered, they are stored in a buffer, and they have not to be sent again, since they are already received, they are perfect, and they have given the acknowledgement, right? So whatever is perfect, whatever you have sent and that is perfectly secured, that is in the buffer, and if anything have been lost or damaged, that is to be retransmitted, right? Now selective repeat ARQ is used in the data link layer for error detection and control. So here the concept of error detection as well as error control is coming, right? The sender sends several frames specified by a window size in the selective repeat without waiting for individual acknowledgement from the receiver, as in go back and ARQ. Obviously same thing is happening here also. So here this particular thing, that we have not to wait for each and every particular your acknowledgement, we have not to wait there. Okay, so here working of this selective repeat ARQ. So let's see what is happening here. So in selective repeat ARQ, only the erroneous or lost frames are retransmitted. Obviously that is the main thing, that the particular thing, this is we have to only send those or retransmit those which are erroneous or which are lost frames, right? Okay, let's shift this one here, otherwise we are not able to see. Okay, now so this is the thing here. So while correct frames are received and buffered, correct frames are received and they are being buffered. Okay, so this is the thing. Now while keeping track of sequence numbers, since we have some sequence numbers here, again as in sliding protocol, so sliding window protocol, some sequence numbers are there, the receiver buffers the frames in memory. Okay, so the receiver what is doing, it's taking, is this just saving these all things, that is the perfect frames in a buffer. So obviously that particular frames which are in the buffer, it is going on taking the numbers, okay, the serial sequence numbers, and it will send an NACK. It's a new term, that is your NACK. Okay, so this is the NACK, which is the negative acknowledgement. Until this particular protocol, we have studied about the ACK, that is your automatic that is your acknowledgement for the correct one. Okay, now this is new term which is there, that is NACK, that is your negative acknowledgement. Now you are getting some negative acknowledgement, right? So for only the missing or damaged frames. So here if you are getting any frames which are damaged or which is missing, in that particular case we are sending, the receiver will be sending you an NACK, that is a negative acknowledgement. Okay, this concept was not there in the previous protocols. This is a new concept which is only in this protocol you are getting. Okay, so the sender will send or transmit the packet for which the NACK negative acknowledgement is received. The sender will only send that particular frame for which it is receiving an negative acknowledgement, that is your NACK. Okay, now we will see how this is processing, how this whole process is going on. Okay, now let's see. Now let's take an example to understand the above point. Suppose there is a sender and receiver and 11 frames to be sent, and the frames are numbered from obviously 0 to 10. Okay, n minus 1. The size of the window n decides the sequence number of the frames. That's also same thing as we have discussed previously. For better understanding, we have taken the running numbers. That's why we have taken the running numbers, that's from 0 to 10. There are 11 frames in total. Now let's take the sender's window size to be 4. We have already discussed about the window size in our first protocol, that was the stop and wait ARQ. You can see there in that video, which means the sender can send 4 frames before expecting any acknowledgement from the first frame, which is 0. Now let's see how we are processing with this particular ARQ. Okay, so this is the whole scenario. This is the sender, this is the receiver. The window size is 4, and what will happen? So each and every time 4 frames will be taken at a time. Okay, now here you can see the size of this particular window is, that is 11, and we have 0 to 10 frames here. Okay, and the window size is our 4, right? So this is what is the scenario here. Now let's see what next we have to do. In next, the sender sends the first frame, which is 0, obviously. Now when 0 frame will be there in the current window, the sender will send the next frames in the buffer since 0, 1, 2, 3. So here what were the size, that is 0, 1, 2, 3. So these were the particular things which were frames which were in the window. So 0, 1, 2, 3, because the sender can send 4 frames without expecting acknowledgement from the receiver. So this is the fact, that is window size up to, what is your window size, up to that particular size, that particular frames can be sent by the sender without waiting for an acknowledgement. After sending this, obviously if it is receiving an acknowledgement within that particular time, then obviously next frames will be sent, but which is in the buffer. But if it's not getting any acknowledgement, it will wait after sending this 4 particular frames. Okay, so this is the work of your window size. Now here you can see this is our window size 1, 2, 3, 4. Now what is happening here, since our window size is 4, so 0, 1, 2, 3, this is the thing which is within the buffer, and it is sent here. See, 0, 1, 2, 3. So these particular frames are frames from the sender to the receiver. Okay, so this is our first function. What we are doing, we are sending the frames which is present in the buffer, that is 0, 1, 2, 3. Now the sender is expected to receive an acknowledgement from the receiver after sending these 4 frames. Since the size of the window is 4, we are sending 4 frames. Now the sender is expecting an acknowledgement from the receiver. Now let's assume the sender received an acknowledgement for frame number 0 from the receiver. Now obviously the sender is waiting. Now the receiver is sending an acknowledgement. So this is the acknowledgement which is being sent. So this is the acknowledgement for frame number 0. Okay, that is, it is F0. It is getting an acknowledgement, sorry, ACK 0. So it is getting the F0, that is the, for this frame, particular frame, it is getting an ACK. That is an acknowledgement for frame number 0. Okay, so now done. So this 0 is complete now. Now it will shift to the right, like up to this. Okay, so now let's see what next. So it had already received, so 0 frame is completed now. Okay, now next function, frame 0 is sent and acknowledged. Complete. The current window size is now 3. So obviously it will shift and it will make it 4. The sender will send the next frame from the buffer, which is 4, and the window that is sliding. Now the window is starting to slide. Okay, so next frame which it will send, that is your 4 number frame. So it is now sending the 4 number frame. Done up to this, and you can see the window is now sliding towards this side. Okay, so this is the function how the sliding window protocol works. Okay, now the current window size is 4 again. So the receiver acknowledges now frame number 1. Now the receiver is sending you an acknowledgement for frame number 1. Since 0 is sent, now your receiver is sending you an acknowledgement for 1. Now here the acknowledgement is sent, and this is the ACK1. Okay, so this is ACK1. Now frame number 1 is also completed. Whatever function is there for frame number 1, it's also completed, right? So here you can see this function is done. Now next function, next what will happen? Let's see. Now the window slides and the sender will send the next frame in the buffer, which is frame number 5. 4 send. Now we are giving the 5 number frame, and the window again slides. Whenever it is going to another number, the window will obviously slide. Let's assume that the sender is not acknowledging frame number 2 because either the frame is lost or the acknowledgement is lost. Now this is the next function which we are taking into account to show the selective repeat ARQ, how it will work. Here what is happening, for this particular frame number 2, either 2 cases can happen. Either the frame is lost, okay, or otherwise the acknowledgement is lost. Both the cases same thing. But if the frame is lost, the receiver had not received any kind of frame, so there is also an error, and if the acknowledgement, the receiver has received the frame but the acknowledgement it had sent that had been lost, so again the same thing is happening, right? So in both the cases we are taking it that the acknowledgement is not coming, the sender is not getting any kind of acknowledgement in this case. Okay, so now what will happen? In this case, the sender will not send frame 4 and 5 again. Here, in go back and protocol, what will happen? We will again send frame number 4 and 5. Here, it is not happening. And it knows that frame 2 is missing because the receiver would have sent a negative acknowledgement NACK for frame number 2. So, the sender will retransmit frame 2 alone, and as usual, other frames are transmitted. Here, what will happen? The receiver, the sender will know that okay, the frame number 2 had not been received or either the acknowledgement is lost. So what it will do, you can see here up to 5 we have sent. Now it will again retransmit. It had not received a negative acknowledgement yet. Okay, so it will send frame number 2, again it will retransmit. Then what it will do, it will retransmit as usual from 6 to 7. It will not start retransmitting from 2, 3, 4, 5 again. No. Whatever it had already sent, it is not going to send it again. It will just send the frame number 2. Okay. And then as usual 6, 7, the next numbers. That is happening here. Okay. And the window will start sliding. And you have to see the size should be automatically same size. We have to take into account. Now, techniques to control this ARQ. There are several techniques to control this ARQ. Selective repeat, that is first one. In this technique, the receiver individually acknowledges each correctly received packet. It is acknowledging while requesting retransmission of only the lost of corrupted ones. The sender stores and retransmits only the specific packets requested by the receiver, leading to efficient bandwidth utilization. Here the main purpose is the efficient utilization of the bandwidth. Okay, so this can be a technique to control the ARQ. Next, again from here, next what will be the next technique? So next technique will be go back N. That is our previous one. This technique allows the sender to transmit multiple packets before requiring an acknowledgement. However, if an acknowledgement is not received within a specified time, the sender retransmit all unacknowledged packets from the last correctly received acknowledgement. Okay, last correctly received acknowledgement means last ACK, whatever it had received from that particular ACK, it will say retransmit all the frames. This technique is suitable for scenarios with low error rates. Where the error rates are low, you can easily use this go back N ARQ. Okay, this technique. And automatic repeat request, what is this technique? Is it in its basic form is a simple error control technique where the receiver sends positive acknowledgements for correctly received packets and negative acknowledgement NCKs for missing or corrupted packets. The sender retransmits packets upon receiving an NACK. Okay, so this is the thing where an NACK negative acknowledgement is also received. We will see that. Okay, now let's see. Next is about what are the different kinds of okay, one more, that is your hybrid ARQ is also there. This technique combines, it is very rare, so this technique mainly combines the principle of ARQ and forward error correction FEC. It allows the receiver to use previously received packets to recover from errors without requesting retransmission. It is not going to request you for any kind of retransmission. Okay, it is just going to allow the receiver to use previously received packets to recover from errors. Okay, so if recovery is not possible, it can request specific packets using your ARQ. So it is also a technique, hybrid ARQ, which is not commonly used, but it is also a technique present. Okay, so requirements for error control, there are various kinds of requirements for error control. That is your reliability, ensure error control detects and corrects retransmission errors to guarantee data integrity. The main thing is for data integrity, it is ensuring the error control, it is detecting and correcting the transmission of errors, right? Efficiency, minimize overhead for error detection and correction, specifically in resource constrained networks. Okay, scalability, that is adapt to varying different network sizes and configurations and changing conditions. So whatever the size of the network, what is about the conditions, what about the configurations, anything can change, but it will be same, that is it can adapt to different environment, right? Now, error detection or correction use different effective codes like checksums, CRCs, FECs, that is to identify the and correct the errors. Okay, and adaptability adjusts parameters based on current network conditions. Whatever are your current network conditions, it will adjust itself. Okay, it will adjust the different parameters. And example retransmissions or redundancies, etc. Minimal impact introduce minimal delay and overhead. Okay, so it is implementing a minimal delay as well as overhead, avoiding significant performance degradation. Whatever the performance degradation can happen, it is going to just avoid those. Okay, and security is the main purpose, that is detect and handle malicious tampering and data corruption. And here compatibility, that is seamlessly integrate with existing network infrastructure and protocols. So these are the basic things which are requirements of your error control. Now, what are the advantages of selective repeat protocol? So there are many advantages. Efficient data transmission. Selective repeat protocol only retransmits the lost or damaged data frames. You have seen that whatever is lost, that is only retransmitted, or the frames which are damaged, that is only retransmitted. Each and everything is not retransmitted. So saving the bandwidth and improving the efficiency. The efficiency is improved as well as the bandwidth is also saved in this particular case. Obviously it is having a huge advantage, right? Now, minimized congestion. The protocol reduces the network congestion obviously by retransmitting only necessary frames. When it is going to retransmit all those frames from the last ACK, whatever it had got and received, then it is retransmitting all the frames. So obviously it will result in an congestion of network. So this congestion, network congestion, is not present here. It is reducing, this protocol is reducing that one, since it is sending only the necessary frames. Okay, leading to smoother data flow. So the data flow will be smoother in this case. Okay, now faster recovery. Selective repeat allows individual damaged or lost frames to be retransmitted, enabling quicker recovery than stopping the entire retransmission. So it is enabling the quicker recovery. The recovery is very quicker in this case, and it is stopping the entire transmission. It is then only the whatever things it is damaged, that is only sent. So it is giving you a quicker recovery. Okay, so this is also is an advantage of this particular your thing. Okay, now optimize network utilization. It is also optimizing your network utilization. It is utilizing the available network resources more effectively than the other two protocols by not unnecessarily resending all the frames. The frames which have been received, to again send those frames each and every time you are not receiving an ACK, then you are again going on sending, retransmitting. That particular frames are already buffered, so you have not to send. So obviously the efficiency is less and it is not properly utilizing the bandwidth of the network. So these kind of things, it is not happening here. It is utilizing and it is optimizing the network utilization, right? Now, improve reliability. The protocol enhances data reliability by correcting specific errors. It is correcting the specific errors, so obviously it is improving the reliability of the network, ensuring accurate data delivery. So obviously the thing is different, it is more efficient, the bandwidth is used nicely, but it is giving you an accurate data delivery, right, which is improved reliability. Now, supports high error rates. Obviously the high error rates, it is supporting the selective repeat request can handle environments with high error rates as it targets only problematic frames. So you can use this for higher error rates, where the environment have the higher error rates. There also you can implement this particular protocol or ARQ. Okay, since it is targeting only the problematic frames. Adaptive, the protocol adjusts to varying network conditions, adapting its retransmission strategy based on the actual situation. So it is an adaptive protocol in nature. Okay, so again higher throughput, that is due to its targeted retransmission. Since it's a targeted retransmission protocol, it is not retransmitting each and everything. The protocol maintains a higher throughput than other strategies like go back end. Okay, now minimal latency. It reduces the latency by selectively resending only required frames instead of waiting for a larger window of frames to be acknowledged. Since only you are sending the frame, that's not enough, right? You are again waiting for an acknowledgement. The receiver had each and every time it have to acknowledge the frames which you are sending. So this is needing a larger window size for frames to be acknowledged. This is what is reduced. It is reducing the latency since it is only sending the selective frames. So obviously the latency is minimal here. Efficient for large windows, particularly useful in scenarios where larger window sizes are needed, as it avoids unnecessary retransmission of correct frames. Okay, so it is efficient for where the large window sizes are needed. There also this particular protocol is advantages. Okay, now what are the disadvantages? Disadvantages: increased complexity. Obviously the complexity is increased here. Selective repeat protocol adds complexity to both the sender and receiver side. Okay, requiring additional logic and mechanism to manage individual acknowledgement and retransmissions. So retransmissions and acknowledgement, they have to be managed individually for each and every frame, right? So here the complexity is added. A complexity is more than the other two protocols, both for the sender as well as for the receiver. You have to give some additional logic and mechanism, since it have to see whatever things are retransmitted, whatever things are acknowledged correctly. So it have to put some logic there, right? So the complexity is increased in this particular case. Now higher overhead. Maintaining a sliding window for each unacknowledged packet increases overhead. The overhead is increased, consuming more memory and processing resources. So here the memory and processing resources, they are consumed more in this case. Now out of order delivery. Select repeat can result in out of order delivery of packets. Yes, this is also important point, that is out of order delivery. What is that? At the receiver due to potential variations in transmission times and acknowledgement. Since the transmission times are different, since we are here, we are sending the as in your stop and wait protocol, we are sending the packet, we are waiting for the acknowledgement. This is not happening here, right? So here we are sending all the frames, 4 frames or 5 frames, whatever the window size, we are sending those frames, and then we are waiting for an acknowledgement too. So the sending of the frames, the receiving of the acknowledgement time is different. Okay, so this is what is the your out of delivery, out of order delivery, that is of the packets at the receiver due to potential variations in transmission times and your acknowledgement, receiving acknowledgement, requiring additional effort to reorder received packets correctly. So the receiver have to see how to reorder those received, whatever packets have received, which packets are received correctly, that it have to save in the buffer. So it have to do some additional effort, it have to give some additional effort, right? So this is out of order delivery call. Now retransmission overhead. In cases of packet loss, selective repeat may trigger unnecessary retransmissions of individual lost packets, so leading to redundant data transmission. So here what can happen, it can trigger some unnecessary packet transmission, right? Retransmission. So if this kind of retransmission of unnecessary packets is happening, then of the individual packets, then it will go to some redundant data transmission also, right? So this is also the transmission overhead, that's for the redundant data transmission, that can happen in this case of selective repeat ARQ. Now increased delay. The protocol's complexity can introduce delays in processing. So delays in processing can be there. Processing acknowledgements and handling retransmissions, potentially affecting real-time applications. In real-time application, it can increase some kind of delay. So this is also an disadvantage of your selective repeat ARQ. Now synchronization dependency. The protocol relies on synchronized timers and acknowledgement, making it susceptible to disruptions in synchronization that could lead to inefficient transmission. So it is synchronization dependency is there in your selective repeat ARQ. Since it had to see each and every time, it should be synchronized. Since it is having some timers, it had to see when the timers are synchronized, when the transmission is going on, when the retransmission is going on, when the ACK is whatever ACK is received, that each and everything it have to taken into account, right? So it can lead to inefficient retransmission. Despite these disadvantages, selective repeat can still be effective in reliable data transmission scenarios, right? Where packet loss is infrequent and efficient bandwidth utilization is crucial. The main thing is effective utilization of your bandwidth. It is a very good advantage of your selective repeat ARQ. So apart from these all disadvantage what have been shown here, still it is an important protocol. You can use this protocol for reliable data transfer. Okay, so this can be effective in case of higher data rate networks, error networks. Okay, so this thing is a important point, that it is an advantageous one. Apart from this it does disadvantages, still it is better than those protocols. Here also you can see again a thing is had been shown here as a sender, the receiver is there. Here you can see how the this particular thing is sliding, your sliding window, and here the frame 0 is you are sending by the receiver, and here again an ACK frame number 1, they have the size is 2. Okay, so here 0 frame, then 1 frame ACK has received, done, then frame number 2 is lost, here frame number 3 is sent. Now it is say here you it is giving an NAK, that is NAK2 means it is giving a negative acknowledgement here. Okay, so this negative acknowledgement when received, it is again sending frame number 2. Since negative acknowledgement is received, it is sending that particular frame for which the negative acknowledgement had been sent. That means either the frame is lost or maybe the acknowledgement. So here in this case, since it's sending a negative acknowledgement, that means the frame is lost, it has not received the frame. So then it is sending again the frame, right? So now it is giving the acknowledgement for frame number 2, frame number 3 acknowledgement received, frame number 4, frame number 5. Okay, now negative again it is getting an ACK for frame number 4 which is lost now. Okay, now the acknowledgement is lost in this case. Here the frame was lost, so it was sending a negative acknowledgement, right? What is happening in this selective repeat ARQ? Two cases. Here the frame is lost, so it is sending a negative acknowledgement, I have not received the frame. So this is what is called the negative acknowledgement. But here it is receiving the frame number 4, but the acknowledgement when it is sending the ACK, that had been lost. Okay, in that particular case what will happen, it will again send frame number 4 and it will receive the ACK. But other frames are normally they are going on. Whatever thing, whenever two cases can happen, whenever the receiver is receiving, it is not receiving any frame, the frame is lost, what the receiver will do, it will send a negative acknowledgement, I have not received the frame. In that case, the sender will retransmit that particular frame. Again, if the receiver had received the frame, the receiver is sending the acknowledgement, the sender is not getting the acknowledgement is lost. In that case, what will happen, the sender will wait for a particular time, that why the receiver is not sending anything, it is not sending any kind of acknowledgement. In that case, the sender will again retransmit that particular frame, then it will get the acknowledgement for that particular frame. But within that you can see the other frames which are going and which are receiving the acknowledgement, they are continuously going on, they are going on as per the sequences in the sliding window, that is whatever the sequence is within the window, they are just going on sending and receiving the acknowledgement. Only the twist is where some kind of your erroneous activities are there, that is your loss of frame or loss of acknowledgement, at that particular time these things are happening, that is the retransmission and again getting back the acknowledgement. So that's why it is a more complex one than the others, but it is more advantageous than your other protocols. Here the chances of error are very less, since I am not receiving the particular frame, I am sending a negative acknowledgement. If I am getting the frame, it's okay, I am sending the acknowledgement, it is not received, again retransmission of frame is done. So the error chances are very less, and the bandwidth is also utilized nicely, and you can see here the whole bandwidth is utilization is also perfect, and the congestion, whatever the network congestion, that is also less. So this is a advantageous ARQ in comparison to those which we have already studied. So this is what is there in your whole selective repeat ARQ. Now if you have any kind of question related to this or related to the previous things which we have already studied about your go back N or your stop and wait, if you have any kind of doubt, any kind of queries, you can ask me in the comment section. And if you have any suggestions or any topic which you want me to discuss in this class, so you can ask me that also. And if you like my channel, then please, if you have got any advantage from this class, then you can like, share and subscribe this channel, and you can share this with your friends also. Till then, we will again meet together. We will again study some other subject. Okay, till then, take care and goodbye. Bye bye.